doing any course on systems and uh, things which are related with the machine learning and artificial intelligence. So I have a video over here. You can all go to this link and watch this over, right? So we'll share this link to you all. What machine learning is doing is it is using different aspects of the structure that we are referring to. For example, the first part is OCR. The second can be the speech recognition. We have product recommendations, predictive analysis. We have dynamic pricing being associated with the machine learning part and inventory level predictions. So if you see all these aspects over here, we are talking about almost each and every aspect of our life that we are doing these days, right? So normally we are spending a lot of time on our mobile phones and doing one of the things or the other that I've tried to mention. And in all these cases, machine learning is playing a huge importance in this case, right? So what we have is we have a few examples to quote before we start the things. It is product recommendation system using machine learning systems, right? So what you have over here is this particular chart talks about complex scenarios that we normally encounter, but how machine learning has helped us in analyzing and effectively ensuring that we get the right thing in a small amount of time, right? So if you see over here, for example, you're viewing a jeans or a pant or some clothes that you want to buy, right? And you have previously carted something else. So target one for machine learning would be talking about how to give you examples of the jeans part that you're looking forward, right? And then the previously carted items will also help it analyze certain things that you normally are looking forward for certain things. Similarly, there are different segments over here. You may be searching for different type of transactions while you're traveling, while you buy some grocery for yourself at your homes, right? These are some of the things that normally we try and do, and we are uh, familiar with what we are trying to do in these cases, right? So product recommendations is something that machine learning plays a huge role. Another one is speech recognition. We are using this a lot these days while we are talking on our mobile phones. The phone listens to us, goes to the directory and dials the number or even types it for us, right? So it is letter recognition, word phrasing, meaning interpretation, and how these things are done using the artificial intelligence and machine learning is something that we want to understand. So how machine learning works is the next part that we need to understand. See, we have a huge data these days, which can be something that we have to analyze on ourselves, right? And if you see, data explosion is something that is being encountered by many companies these days around us, and this data explosion can be understood by this chart. So if you see over here 2005, and if you see 2019, and then so on, right? We are crossing 4 to 5 more years, but right now the data is too huge to handle. So machine learning is talking about three aspects over here: supervised learning, unsupervised learning, and reinforcement learning, right? Supervised learning talks about classification, regression, ranking. Unsupervised learning refers to clustering, association mining, segmentation, and dimension reduction. And similarly, reinforcement learning talks about decision process. So we'll be talking about all these three today, while I'll show you the systems that we want to design. Supervised learning is something where we give supervision, learning with known labels, that is raw data. And then what we do is we take a sample data out of this. An algorithm is coming into picture where the system is trained for this algorithm, and then it analyzes, manually verifies the things, and then leads to high production level. So data model training, testing, and running is a very simple phenomena that we do normally with supervised learnings. Classification on this particular basis is done in different ways where you use different classifiers to analyze the given data based on the algorithm, which learns and then performs the steps, right? So we have three steps over here. If you see green part, blue part, and the red part, the third step is basically the error monitoring that we do in these systems, right? So now, what is the regression analysis happening? So there is a line that you see over here, right? This particular line over here. We have the samples and then the regression part. So the red dots that you see over here are the samples, and this is the regression line. Best fit analysis is taken out of this to determine likely what would be the outcome of the analysis done by the different algorithms that we are using. Unsupervised learning is basically the clustering that we refer to on raw data, and then we cluster them into different areas, as you see over these circles that we have drawn. And this is clustering them into a particular group and then identifying or understanding the data accordingly, right? So there are the third part is reinforcement learning, where it is reward based and humans are actively involved. Plus, the intelligence that we already have is taken into picture, right? So, the simple name for this is reward-based learning, as I can call. I'm quickly going through these things, and we'll talk about now how AI and machine intelligence, when come together, has helped us out. So, what is AI? Basically, turning test is the one that can help you out. There's another video you can watch on this. We have human behavior and we have intelligent behavior. That is human behavior talking about unintelligent human behavior, and intelligent behavior to humans. We are not referring to that, but there is a turning test which is comprising of how both these figures combine together to produce a desired result, right? So you can see this in different ways where we have computers playing games. We normally have played this, chess and other things, right? So here, the use of AI and machine learning is taken into two halves together, basically, right? Then you have neural networks and deep learning, which help us analyze the things in a better way, right? So we have input nodes, we have hidden nodes in this, and then the output node based on the intelligence of the system, where the neural network comprises of different ML nodes working together into a system, and then AI plus machine learning, leading to deep learning model. I don't know whether you're able to see this, but this is deep learning. So if you see the previous part, it was this structure where turning test was being performed in the center. This is deep learning structure, right? I hope you are following the things that I'm trying to give to you right now, and I hope that the things are pretty much audible from my side also. Current applications which are using all these aspects are the customer services, the Siri, Alexa, trading, marketing, navigation, right? And then what we have is we have different machine learning platforms which are using these things, right? I've given a few over here, and I know you know a lot more than this. So if you see, they are right now coming into pictures hugely referred by many individuals. This is not a break, but what I'm trying to do is I'm trying to give you an overview of AI and machine learning before I start using them into practical systems. So now what I'll do is I'll first show you what platform am I talking about, and then how to use it. So I'll just go back to the room again to ask or listen to what you people want to say, any messages over here till what we have done. Anyone who can just type and say whether he or she knows something about LabVIEW. We'll have to start this, and then we'll be talking about practically using this to design systems, basically biomedical systems.
Sir, what I know in the lab view, actually
Yeah.
last year we did one project for like plotting the graphs. So for mechanical
Okay.
vibration as a mechanical point of view project applications for gears with
Right.
yeah, gears which has some good condition, health condition, and some gears when it is break. We collected the data. Those data we have set in the lab view software to plot the graphs, sir.
Great. Great, great. So
That thing
you are aware about
I use,
how
yeah,
LabVIEW works,
last,
right?
yeah, last time we used for the project for mechanical project
Great.
application.
That's great. That's great to hear. Anyone else who knows about this? Okay, fine enough, fine enough. No problems. What I'll do is I'll show you first what we are talking about. When you write in Google about this particular block, we write National Instruments, and it takes to use you to a site called as National Instruments or ni.com, and this is the company which is developing this particular software. So you see LabVIEW Suite Plus, right? So we are referring to this particular block over here, and we'll be using it in designing different structures using referred for biomedical systems, specifically for biomedical systems, right? So today we'll be okay. We'll admit him. So we are I'll tell you about how this LabVIEW software would be used first, and then I'll show you how the systems are implemented using it, right? So navigating through LabVIEW is something that we need to start with. And when you click onto the icon, once you install it, you have to click onto this icon called as LabVIEW over here. You can see it over here. This is the shortcut. And once I double click onto this icon, you will see a window opening in front of you, right? And then this is how this window would look like, right? If you see, we have two windows, front panel and block diagram, right? This is when you open it for the very first time. So I'll take you back to the slides first, and then we'll come back to the practical system. So what we are trying to refer today is this interesting software which helps us easily design complex systems into a real world, or helping us interact with real world also. So we'll talk about these things. What is LabVIEW, Project Explorer, or parts of VI, right? I just showed you these two things, front panel and block diagram, and we'll be referring to them also over here. Plus how to search different things, selecting tools, data flow, and building the sample VIs. I'll talk about what this LabVIEW is. So this is a graphical programming language. The best part of this language is you don't have to write any codes in this, right? It is totally graphical. You have to just uh, place the things onto front panel and the background block diagram configuration, and then you will be able to use it effectively for designing the system. So this is the best part of the software, that this is graphical programming language. So you don't have to learn any new code, or you don't have to shift over from one part to the other and then understand what to write in the beginning and then what not to write. Or you have to scale between different, you don't have to change even operating systems. Whatever you are using, it works on all the operating systems. So just when you're downloading the software, you remember you're downloading it for which operating system, Windows or Linux or Unix, whatever you're using, right? So it works in all the environments, and this is the best part. So what we have is we have core one and core two part, but right now we'll talk about how basic aspects of LabVIEW are taken into consideration. So what we have is we have front panel, we have block diagram, icon and connector pane. So I'll just show you these things, and then we'll practically see what they are. So this is the front panel structure where you can place different items or simple graphical tools that are used here. And then this is the connector pane. So this is an important structure, but right now I don't know whether we'll be able to use it effectively or not. And this is the background part here, which you see block diagram configuration. So whatever you're placing on the front panel will be automatically placed on block diagram configuration. You have to connect using the block diagram, right? So this is basic idea of how you do it. I'll show you how to do that. So okay, I'll just take you through it because I wanted to do practical work with you. So just have a look. If you're able to see my screen completely, right?
Yes,
So
sir.
once you open it, you have to go to File, New VI. I've already done that, and the shortcut is Control T. So when you press Control T, both front panel and block diagram would come simultaneously in front of your screen, right? So this is the shortcut. Now the part is when you right click onto this, there is a complete menu appearing in front of you. All the toolboxes, all the features of the processor are basically in front of you all, and then you can do whatever you want. But right now, because nobody is knowing to use it, barring a few. So what I'll do is I'll design a very simple structure for you, where what I'll do is I'll go to say a numeric part, and I'll place a knob, right? So if you see, when I placed a knob, the structure has already been placed in block diagram also, right? I use another knob over here, right? I'm using two knobs. Then I can use an LED for an output part for me, right? And what I can do is I can design a very simple structure going to the mathematical part. So when I have to go to mathematical part, I have to go here and then I add these two things, right? So simple adder. This is a structure for an adder, and then a Boolean function, or okay, because this is a Boolean function, so it will not recognize it. So the output of this adder can be placed to an indicator directly, right? So I'll remove this. Uh, Now what you do is I'll take this over here and change the number to 100. Here also I'll do the same thing, change this number to 100. And then if I'm just expanding it, so I hope you're able to see this, right? And yes or no would be quite helpful for me. So this is a very simple structure that I've used for creating an adder over here. And when I run this, it will show me an output, right? Right now, because it is 0, 0, the output is 0, 0, right? So let me just change the output. I hope you can see the change happening over here, right? I hope you're able to see this.
Yes, sir, it is visible.
So this is very simple programming. I have not written any program, but I've just done the things, right? Now, what I can do is I can even go for measurement of temperature using a thermometer over here, right? And then I can create some system. I'm not going into that detail, but what I'll tell you is how to run this continuously. What you need to do is you need to go to structures and insert a while loop into this, right? So when I insert a while loop, this will go on going on continuously till I stop it, right? So this is the stop button that is created automatically when I uh, place the indicator over here. Now when I run this and you change the output, it is now running continuously, right? And I can stop it from here. So very simple structure that we have tried to design using this part. And there are so many graphical tools. I can show you another one. I'll quickly take you through that because we will be talking about biomedical systems. So what I'm doing is I'll go to block diagram configuration. I'll go to an express VI input part and then a simulate signal block. Right. Now, this simulate signal block is something of the thing that you use in your labs normally as a function generator, where we have amplitude, frequency, data offset, etc., over here, right? And what I can do is, again, I'll use this knob and I'll connect this directly with the amplitude part, right? It is very simple, just taking, going to the point and then taking the wire, right? Then another knob and giving it to the frequency part, right? I right click onto this, create a graphical indicator. So the graphical indicator comes over here. I hope everybody is able to see this now. Again, what we can do is we can expand these knobs to certain values, right? I can take this value to 1000 maybe, and this again to 1000, right? Great. So I hope you are able to see this clearly now. I can still enlarge this one. And I told you to run this continuously structure. I'll use a while loop for me so that the waveform looks in continuous manner. So again, a stop button is added directly to this particular block. So if you see, we have a stop button here. Now, when I run this, we get a straight waveform, right? Because there is zero frequency and zero amplitude over here. Now see what I'll do, and I'll change the things, and you will see some waveforms appearing. I hope you're able to see this.
Yes, sir, visible.
And this is
And
something that you normally see in your books, the waveform like this, right? Right?
yes, sir.
Great. So we have very quickly been able to design a very practical system which is measuring some sine wave for me. And I could have used it for amplitude modulation or frequency modulation, introducing the formula inside it and whatever you want, right? So if you see how effective it was to work with this system and how easy it was. So I'll go back to the room to ask you whether you were able to understand and effectively see what I did. Anyone who can help me out with this?
Sir, pardon. Sir.
So I like to know whether you were able to understand what I did,
Yes, sir. It's
right?
yes, sir.
Great. So I'll just go back to these things and then quickly take you through this. So I've already talked about how the system is working. We have front panel and block diagram configuration. I showed you both the things. This is the front panel over here. And the front panel would talk about all the aspects. As you see, we have a chart over here depicting the value of or the input and output things. This is the chart part, this is measurement part, this is the uh, knob that we used, and then at the block diagram configuration, how you see these things, right? I hope this is clear to everybody now. So then I'll skip this icon pane, but I'll go to the front panel part to show you how we are running these aspects over here. We have this run, continuous run, stop, pause, etc., etc. So we can make use of these things when and if required from us, and controls and indicators can be placed effectively here. Then we have different designs, right? So this is the classical part over here. This is silver control, this is classical control, this is system control. So all these things are available inside it, right? Numeric controls, indicators, push buttons, strings, etc., etc. And how you run them in block diagram, I've just shown you. I'm just quickly taking you through this, right? So you can work out these things where I can, uh, I think we did this same example, but I didn't mention the values. So if you see, we have used a multiplier, another multiplier, and we are trying to find out the area of triangle. So if you write a program in C for this, then it would take some time to for this particular purpose. But yes, we are able to do it very effectively using LabVIEW part. So we can do these things at a very simple click. I use this Express VI and I showed you how to do them. And this is an important part. I'm taking you quickly to this particular point where we have different colors for different aspects: floating point, integer, string, and boolean. So each color is representing the type data type that we are using, right? So we have boolean in green, strings in pink, integer in blue, and floating point in orange. And this is scalar. Single line is scalar, a thick line is 1D, and double line is 2D, and similarly it goes on, right? So we have a LabVIEW help also. If you don't understand anything, you can go to that and quick drop menu where you can find different toolkits over here. So control palettes and function palettes. So you can search from them and execute it, right? So I'm not going into this quiz right now because we don't have that much time. But yes, building a simple VI is what I showed you, where I used Express VI to analyze it. Now I quickly take you to the ECG part and the biomedical toolkit over here, right? So let's see what this biomedical toolkit can do for us now. So, okay, I'll go back to this structure and I right click onto this. Now here it is biomedical, right? You can see this. If I pin this, the biomedical part will be pinned over here. And then you have different aspects of biomedical signal processing being done through this. So we have ECG, EMG, EEG, pre-processing, right? You can talk about all these things over here, and then we have medical interpretation where we have ISO surface. I'll show you this example, medical image surface or ISO surface, how effective it can be and how easy it would be designing. So we'll be using the ECG part and this medical image processing structure, right? So I'll show you an example for the 3D imaging first, where the or we'll start with the ECG part and then we'll go ahead to the 3D part, right? So if you see this VI, I've already created it with you. Now this looks a bit complex over here. I'm not taking this into consideration right now, but if you want to analyze an ECG signal, which is already there with you, so how easy it can be for you to analyze that, right? I'll just show you this. So I run this. Now we'll just expand this. I hope you're able to see this. So this is a very simple ECG curve, right? This is normal ECG for anybody. If any doctor sees this, he or she can tell by the look that this ECG is pretty normal, right? I hope you're able to understand this.
Yes, sir.
Okay, I'll again expand this for you. Let me just stop this out. Okay, now I hope you're able to see this clearly, right? So this is a normal ECG data that we have bought and we are trying to run this using the system, right? And this is how we are able to do it. I have another data which I run, and now you see the output being shown in a different way than the normal part. So this is tachycardia. If you are familiar with the terms of biomedical structures, then tachycardia is something which is a disorder, right? I hope you know something about it, or shall I tell it?
Yes, sir.
Hello?
Yes, sir. Yes, sir. Then-
Right. So
Yes, sir.
this is a medical term for a faster normal heart rate, right? So in this case, the normal heart rate was heartbeats were, if you check out again, I'll go back. It was 78. Now see, these are the parameters coming below, right? It was 78 beats per minute. Now tachycardia means 119 to 120. That means it is over 100, right? So the normal part was to see and tell that what we have is a heart rate of 80 to 100 as a limited structure. But right now in tachycardia, what we are having is 120. Similarly, we have a hyperkalemia structure type scenario. So I have these things because I was working with these diseases, right? So I have used the same part and I'm calling or using the same data to analyze effectively how ECG in that case can be analyzed. This is hyperkalemia, that is too much potassium in the blood. The heart rate is normal, but yes, the parameters, other parameters are not normal in this case, right? So if you see them, these would be these things are the ones that we don't actually consider while we are watching them. Now have a look over the normal part. This was the normal part. Tachycardia means there is some problem here, and hyperkalemia, this particular thing is over exaggerated, right? So there is a problem in the ECG part over here, and this problem needs to be resolved effectively, which can be seen directly from this ECG feature, etc. So it is giving you all the intervals. So now in this slide, what I've shown is this is the normal ECG part where you see PQRST curve over here. We have a PR interval, we have a QRS interval, and an ST interval, and then PR segment and ST segment over here, right? So if anything is corresponding to this curve, it is a normal ECG. So earlier one was particularly a normal one, right? I hope you get it. Anyone who can say yes or no would help me out.
Sir, sorry, sir. I didn't hear. Hello.
I
Yes,
hope
sir.
you've understood what I'm trying to say in this example, right?
Yes, sir. Yes, sir. Yeah.
So if you see over here, this ECG feature, etc., is extracting all the features that we wanted in a particular structure. We have heart rate standard QRS, amplitude, PR interval, QT interval, ST interval, and an ISO level over here, right? So
Yes, sir.
this is what we can talk about in this case. And then what we have is we have a scenario of different type of abnormalities in the ECG analysis. So again, I can reset it. And then we can extend it. So this is the normal curve. Again, I'll repeat this, right? This is the normal curve that we are getting, and then how the features of different other can be compared with this. So artificial intelligence, where it comes into picture. So artificial intelligence comes into picture where we have analyzed this through the software, and here only I use my own data set to predict what medicine should I take if my ECG is not normal and it is talking about tachycardia. Right now, I've mentioned it over here, but AI and machine learning can help me directly extract these features and then recommend a medicine for me, which is directly mentioned over here that right now I should take this for my benefit, and he can help me out with the other things, right? I hope you understand this.
Yes, sir. Yes, sir. It is clear, sir.
Great. So we move ahead and now we talk about the next part, that is the ECG signal analysis being done through different parts. So what I'll do is, see, I'll share these slides with you. I'll just go to the HRV analyzer now and then show you how this thing can be analyzed very effectively as far as the ECG part is concerned, how easy it is for us to analyze the things. So again, the data is pre-fed into this. I'm not saying that I have not taken the data. I have taken the data. This is the feature extractor over here. You see, I showed you about this, how system can be trained. This is the Pinocchio plot, and then we have an FFT analysis, AR spectrum, and STFT spectrum part, right? This is from the ECG feature array, right? So I don't know, it has got stuck right now, so I'll have to switch this off. I'll just again reload it. Just give me a second. Right. Now, if you see over here, we have a fetal ECG signal extraction being done in this example. And what you see over here is pretty interesting aspect that we have an adaptive filter, a noise cancellation, and a signal structure. And then this is the ECG analysis being done, right? So we have a maternal abdominal ECG, we have a maternal thorax ECG, and a fetal ECG being shown by this. And all these parameters can be seen by expanding or increasing the structure, right? So we can compare them together over here, right? So this is a signal extraction being done on the other part, and then we have something like as a removal of noise from this part. So noise cancellation is what I can show you over here. Now, if you see, we have a noisy ECG being treated with COM filter to produce a correct signal, right? I can run this continuously over here to make sure that I hope you're able to see this.
Yes, sir. It is visible.
Right. So these are some of the things that we can effectively do with this biomedical toolkit over here, where we can remove the noise, wideband noise, and we can do a lot more things. We have a UWT signal also, which can be done. I can show you another example where, okay, when I run this, see, if you can see this over here, we have a threshold value and deterrent settings being done. So uh, now, if you go back to this particular block, this is how simply it can be done. This is the direct block available, right? You can press Control H over here, and then what you get over is a very simple aspect that this is what multi-scale peak detection structure. And I've used this just this, entered the value, and we have analyzed the signal, right? So similarly, I'll show you a very interesting example now. And this is about 3D image reconstructor, the one that I just showed you, how this can be used. I'll again go back to this particular block and then show you in biomedical structure. We have to go to medical imaging, and this is isosurface, right? Now, this isosurfacing is the one that I'm using right now. And I'll show you the complete example over here, how this can help us out. So just have a look of what I'm doing. We have a 3D scan, basically 2D images we have. We convert it into 3D surface plot. So this is the top image of a skull or someone who was not in a proper situation over here, right? Now you see, this is the 3D image being created, right? Are you able to see this? I can even rotate this out. And what I'll do is this ISO value, just have a look of what I'm doing. Okay, I'll just move into some direction where you are able to see something. Earlier, it was at this point where we were only able to see the skull part itself. We were not able to see any human aspect into this, right? This was just a skull which was created into 3D image for us. Now I'm using the value of ISO and then how this is helping me recreate the image. I hope you're able to see this now, right? So we are able to now recognize this particular person, who he was or she was, and how effectively we can uh, do the or check out where and how this skull would have been found, and then any analysis can be done onto this, right? Earlier, it was just a scan, right? So I can add more to this, but this will become more simple. Marks would come over here, right? So the best option was coming over here. Now, how AI and ML is helping in designing this is very interesting. At the background, the system was trained to make sure that it provides me the exact structure of this particular image scanned over here, and then this ISO value is helping me recreate this image over there, right? Now, if I reduce it again, I go back to the skull image, right? I again go back to this. I have to keep it around this part so that I am able to see the 3D structure at least around 100. Right, now I hope you are able to see. So we can rotate it. We can rotate it in 3D part and we can analyze it according to what we want, right? So in biomedical structures, this becomes a very huge help for us, where we can analyze the things and then make sure that we are getting the correct results using this particular block. ISO value, or this block that I showed you, is utilized for this particular purpose, right? Mm, okay, so fine enough. So there are no messages over here. Any questions you want to ask till this point?
No, no.
So this was all about the biomedical part. I have already shown you how these ECG signals can be treated, and then how we can use the ECG feature extractor. Also, how I'll show you this example also, HRV analyzer and the biosignal part. Just give me a second. So this is basically about the RR interval, right? If you see over here, right? So again, this is the HRV ECG feature extraction analyzer, right? Directly I can use it. So that's it from my side, and this was the last part, was the ISO value structure that I had to uh, talk about, and then even the filtering becomes pretty easy for me as far as the biomedical part is concerned. In all these cases, the system has been trained to perform the action accordingly, right? So now I would like you to ask few things if you want. I'll just take you through these things, right? So I'll share these slides with you. Even this biomedical pre-processing part can also be shown. Just give me a second. I'll have to check this out. Okay. In any case, till then, you are free to ask if there are any questions over here.
Yeah, dear participant, if anybody wants to ask question, please feel free. You can put the in chat box.
I'm able to locate it right now, but yes, I'm open with the questions part till I find it out. I had kept it somewhere, but in any case, कोई बात नहीं.
So
Anyone who
this
wants
is
to ask,
yeah. So this is a scanning image. We are visualizing in 3D image, 2D.
pardon, sir,
So
this
this
is.
is this one brain like
Mhm.
this is what we are visualizing in 3D image, sir.
Sir, this is the scanned images in 2D. It was then later on converted into 3D, right? And then I have used the ISO value to make sure that we see some output out of this.
Okay. So like any or scanning image we can visualize in 3D.
Yes, sir. Yes, sir. Yes, sir. That is how easy it was, sir. You
Okay.
can use any of these scan images, even you can scan it afterwards and then place them together. But yes, you require these three uh, views, right? The top view from this part, the back view, and then the side view.
Okay, not only like a brain or we can use some any
Yes,
like
yes, yeah. You can do it for any of the parts.
parts of the body.
Yes, yes.
Sir, I think hope we have used this LabVIEW software for vibrational analysis. Same case.
You can use it for any of the types. What I'll do is I'll just right click and show you how effective it is for all. How many toolkits are available, by the way, right?
Yes,
So
sir.
if you see over here, it is not only the biomedical structure, but robotics,
Yes.
electrical power, RF communication, sound and vibration. Then we have a test stand, and let me go above Signal Express. We have data communication, signal processing, connectivity, control and design, mathematics, vision and motion. You name any, everything is there, sir.
Fine, fine. Good.
I think many of us are aware about NXT Robotics. So NXT Robotics has placed their toolkit in this.
Yes, sir.
Hello,
Yes, sir.
hello.
Yes, sir.
Yeah, yeah. Are you able to
Yes, sir.
hear me, sir?
Yes, sir. Yes, sir. We are able to.
Any other questions, sir? I'm just waiting for that.
Dear participant, if anyone anyone have any doubts, please let you ask it, sir. Or you can put a test in the chat box.
Right. So I have another example for all of you. This is the biosignal pre-processing comparison structure. Now, if you see, we have a ECG signal, right? Again, all these are signals which have been taken from data itself, right? I'm reading them, and the analysis is being done. Filter, integral derivative, deterrent signal, average rectified signal, RMS value. I can change them accordingly to make sure what type of structure I want, right? So these are the things. Another can be for EEG signal over here, right? And then EMG, whatever signals you have. So even I can change the filter. Notch filter can be used, a low pass filter can be used. I can use a derivative output in this case. I can use a square output in this case. So whatever is uh, available to you, you can utilize it to analyze the signal and then produce the results accordingly, right? Now, it is not that difficult as far as lab view is concerned. I don't have to write any code. This is the best part of the system. Right. So I'm open for the questions if any questions are there. But if there are no questions, then that's it from my side, sir.
Yes, sir. Sir, what is cost of LabVIEW? Is it freely available or we need to?
All right, sir. So very right question from your side.
Yes.
Actually, this is not freely available, right?
Mm.
So we have to buy this out. Otherwise, student editions are free.
We do the same kind of simulation with that student edition or in?
Yes, sir. You can do same kind of simulations in that. The only part is that you need to install the toolkits. Whatever your toolkit you are using, that toolkit has to be installed, sir. But unofficially, there are. See, you're using all the softwares, right?
Yes. Yes, sir.
I'm just saying unofficially we are using all the softwares that are available to us,
Yeah,
right?
yeah. But what?
Even
Yeah,
so,
what?
this also you can
Yeah, from
work
the
with.
LabVIEW software, we will get the some output like in the Excel sheet and all, so that
Right,
we
sir.
can observe it. Sir,
Yes,
is
sir.
it?
Yes, sir. So
Yeah.
I'm using the same thing over here.
Yes, sir. One question was asked by KV Verma Lakshmi. Example related to biomedical applications are available in LabVIEW. Is it available, sir?
Sir, see, examples are always available. Even you go to LabVIEW website that I showed you over here. There are so many examples that you'll see, right? The only part is you need to understand how to use them. So you have a community structure over here which share the examples, right? Now you can see it. ID exchange user groups, and these are example programs, right? So when you click onto this, many of the researchers have shared their codes with you people so that you don't have to waste time on setting up those things. You can just directly download the examples and work on, add the things onto that, just like you're doing these days in open access structures. Madam, biomedical applications, you can use MATLAB also, very effective in that. But what I can show you here, another thing, because you have asked it right now. So, see, even a math code can be written in this, right? How you can do that? So, we have MATLAB integrated inside this LabVIEW. So, what we need to do is need to go to structures, and this is the math script. So this is complete MATLAB software inside it now. You can write your MATLAB code here, and then you can run it as you do in MATLAB. So I hope I was able to answer that, man.
Yes. Yes. Anybody, any participant need to ask questions? Please, platform is open. You can ask.
Fine, sir. I believe there are no questions to be asked right now from the participants. So that's it from my side. Thank you very much, sir.
Anna.
Sir, shall we end it? Are you there?
Yes, sir. Yes, sir. 2 minutes, sir.
Yeah, please.
Yes, sir. Can you hear me, sir? आवाज नहीं आ रहा. Yes, sir. Dear participant, next we'll move for the vote of thanks. Yes. Audible. आवाज आ रहा? Yes, sir. Yeah. So it is my privilege and pleasure to propose the vote of thanks on this enlightening day of our 1 week FDP on emerging trends in medical additive manufacturing, AI and ML approach. First, foremost thing, on behalf of the Department of Mechanical Engineering at Lord's Institute of Engineering and Technology, I extend my heartfelt gratitude to our distinguished speaker, Dr. Nikhil Kumar Garu, sir, Assistant Professor in Department of Electronic and Communication Engineering at University Institute of Engineering and Technology, Kurukshetra. Dr. Mariwala's sessions today on AI application in biomedical system, ECG signals, analytic and 3D visualization using LabVIEW toolkit was not only intellectual stimulating, but also deeply insightful, sir. Is a deep expertise and clear presentation of complex topic like biomedical signals, analytics, and integration of AI in healthcare visualization have certainly left us all inspired and informative, sir. We are truly thankful for your valuable time and enriching knowledge, sir. I would like also extend sincere thanks to our respected organizing committee for their consult, support, and encouragement, without which this FDP would not be possible. Last but not the least, our technical team and coordinator deserve a special mention for ensuring the smooth conduction of this virtual section. Let us carry forward the insight we have gained today into our research, teaching, and academic pursuit. Once again, thank you. Thank you all for making today's session a grand success. Have a great evening ahead. Thank you for all. Thank you, sir, for joining our today's session and accepting our invitation.
Thank
Now
you
I
very
would
much,
like,
sir. Thank you.
yes,
Thank you
yes,
very
sir.
much.
Yeah, now I request
I
my
hope I was
participant
of some
to,
help.
yes, sir, please, sir. Yes, sir. Yes, sir, please, sir.
So I can disconnect now, sir.
Okay, sir. Okay, yes, sir. Yeah, my
Thank
dear
you very much, sir.
participant.
Thank
Yes,
you for
sir.
having me. Thank you very much.
Yes, sir. Dear participant, we have shared the feedback link in the chat box. Please fill the feedback form for today's session.